Welcome back, Honors Algebra 2 kids. We are now on page 83, 4.2 in your student journals. We are actually going to talk about adding, subtracting, and multiplying polynomials today. So what I wanted to show you is just some of these patterns that were kind of something that we would look for on our, that as we kind of do our multiplication of polynomials. And this is called the sum and difference patterns. And this is the square of a binomial and cube of a binomial. What I'm getting at here is these are some of the patterns we've already kind of recognized. So this is kind of the opposite of the difference of two squares. So if I have a polynomial that has a plus b and then a minus b, in other words, if I have here, it might be easier to look at the example. If I have a polynomial where basically the terms are the same, like the x, the 3, the x, and the 3 are the same, but the only thing that differs is the middle term. One is positive, one is negative. What will end up is you'll get this binomial. So basically the middle terms cancel out and you get a binomial as your final answer. So if I distributed this out, what happened every single time that this pattern occurs is that you will always end up with just a binomial instead of a trinomial. In the second one, it says a square of a binomial. This is the one that we as math teachers are really kind of picky about because we want to make sure that you guys don't mess this up. The biggest mistake we see as math teachers a lot of times is if I had like a binomial like x minus 4 squared. I get a lot of people that tell me this is x squared minus 16. And I want you to make sure you know that that is not correct. When you square a binomial, your result will need to be a trinomial. So remember, you're going to distribute that out. You're going to FOIL, however you learned it, and then your result will be a trinomial. The cube of a binomial we're going to get into today, and that basically means same kind of deal. I'm going to use my example of x minus 4. So if I cubed that, what essentially you're going to be doing is expanding this out like 3 times. So you're going to do x minus 4 times x minus 4 times x minus 4. And so what that will result in is that you're going to, do a little bit more work here, but you're going to basically like take 2 at a time, distribute those out, and then do some more multiplication at the end. And I'll show you how to do that here in a bit. Okay, I need you to turn to page 84. So on 84 is this special pattern. So in honors, we're definitely going to do Pascal's triangle. If your teacher in regular algebra 2 has you going through this, or if you're just interested in this, kind of, it's like a little trick or whatever, you are welcome to, watch this part of the video and learn along with us. So in honors, we're definitely going to learn this. There will be some, follow-up questions and probably on your assessments and so forth. What I want you to know is there's this pattern that kind of happens when we talk about Pascal's triangles. I don't know if you know the pattern of Pascal's triangle, but basically the pattern goes something like this. You start with 1, and then it kind of you go like in like a little triangle type thing. So you have the 1, the 1, the 1. And then if you add these two together, it equals your middle term. And if you add these two together, it kind of brings you down to your next term. So notice that when I added those numbers together, I can kind of build off. And so this is a phenomenon that happens. You can kind of extend this over and over and over again. So like 1 plus 1 is 2. So notice that there's 1s all on the outside. So to get this middle number, I added those 2 together and got that middle number. And then for this next row, I added 2 and 1 together to get 3. And then 2 and 1 together to get 3. And then 1 and 3 together, 3 and 3 together, 3 and 1 together. So basically what happens is that you're building this pattern or this triangle. So I'm going to kind of walk through this. What this represents is when you're expanding a binomial, we can use this like phenomenon, this trick to kind of help us, rather than having to like multiply everything out by FOILing, there's a pattern that we can use. So what we're going to represent is this first one is representing the 0 row. This represents the first row, this represents the second row, the third, fourth, and so on and so forth. And so what you'll notice is that each of these rows kind of pertains to one of the rows in your Pascal's triangle. So let me show you how this works. So first, let me just tell you that this is a trick. So you always have the option of just kind of expanding it out. So what we're going to be doing is I'm going to walk you through an example of a binomial raised to a power. So again, you always have the option of just taking x plus 2 times x plus 2 times x plus 2. But I feel like it's worthwhile to at least show you kind of this pattern. So first of all, what you notice is that the power here pertains to the row you're looking at. So if you're looking at a third degree polynomial, you're looking at row 3. So remember, we're starting with row 0. So be careful that you don't count this off incorrectly. So we want to identify which row of Pascal's triangle we're looking at. And what happens here, if we follow this trick, is that the 1, the 3, the 3, the 1. What this tells me is that there's going to be 4 terms in my final answer. The leading coefficient of each of my terms. The first one's going to have a 1, the next one's going to have a 3, the 3, and then a 1. And so what I'm going to do is I'm going to use that information to help me build or to kind of expand this binomial cubed. So you take the 1, so I'm just going to write 1, 3, 3, 1 up here. That's my pattern. And what you do is you kind of do this little trick, I guess, if you will. You take the first term of your binomial, so in this case it's an x, and you raise it to the highest power. And then you take the last term, which is a positive 2, and raise it to the lowest power. So in this case, it's 0. So I'm just going to kind of write that down so that you can see this. So in this example, to get x cubed, you took your first term to the highest power. And then on this one, you took your second term to the lowest power. And then basically what you do is you kind of expand that all the way down. So let me show you how this works. So then you put a plus sign. Whoops, where's my pen? All right, so then you put plus, and then you go to your next term, which is a 3. And then you do, with the x, instead of being x cubed now, you're going to knock that down 1 power. So everything decrease, on the way down, you're going to decrease the power on your first term. And then you're going to increase the power on your second term. So this gets down to a 2, this becomes a 1. So now I go back to my leading coefficient, now I'm on this 3. And so now my x now becomes x to the first power, and my 2 becomes 2 to the second power. So again, the x's are decreasing, my first term is decreasing in power, my second term is increasing in power. And then the last coefficient is a 1, and so my x would be at x to the 0, and my 2 would be at 2 to the third. So once you've kind of done all the work here, just like the little pattern, now you're just kind of simplifying your final answer. So if you look at this, what is 1 times x cubed times 2 to the 0? Well, remember what 2 to the 0 is. Anything to the 0 power is just 1. So this whole term, 1 times x cubed times 1, would just give me x cubed. This one, I have 3 times x squared times 2. So that would give me 6x squared. And then this one gives me 3 times x times 4. So that would give me 12x. And then this one, since the x is to the 0, that just gives me 1. So this would be 2 cubed, which would be 8. So this is how I would expand that polynomial. So again, this is an alternate way of expanding your polynomial without having to like FOIL. Let me go through another example for you, okay? This time I'm going to use something a little bit harder. So why this comes in handy is when you have powers, you're trying to expand something that's a higher power. So we won't go too crazy here, but let me give you one like this to the 4th power. So again, this would be a little bit cumbersome to take negative 2x plus 3 times negative 2x plus 3, 4 times. So the first thing I'm going to do is look at the 4th row of Pascal's triangle. So I know I'm dealing with 1, 4, 6, 4, 1. So I'm going to have 1, 2, 3, 4, 5 different terms in my polynomial. So I'm going to start with the 1. My first term is negative 2x. I'm going to raise it to the highest power, in this case is 4. My second term is 3, and I'm going to raise it to the lowest power, which is 0. Plus, then I go to the 4. And then everything just kind of gets knocked, this gets knocked down 1, this gets increased 1. So now I have negative 2x to the second and 3 to the second. Now I'm on the 4. Then I have negative 2x to the first and 3 to the third. And then finally I have 1, and then I have negative 2x to the 0 and 3 to the fourth. Okay, so this is where this part comes in handy, because now you're going to kind of simplify this and rewrite your final answer. So on this one, I have 1 times negative 2x to the fourth times 3 to the 0. Well, 3 to the 0 is just 1. Negative 2x to the fourth. Remember, you have to apply this power to both. So negative 2 to the fourth. So negative 2 to the fourth. Negative 2 times negative 2 times negative 2 times negative 2 is 16. So this whole thing becomes 16x to the fourth. This one becomes, all right, so I have 4, and I have negative 2 cubed would be negative 8, because negative 2 times negative 2 times negative 2. And this is x cubed. And then, of course, this is 3. So I'm going to do all my numbers first. What's negative 8 times 4 times 3? Well, negative 8 times 4 times 3 is negative 96. And then my powers of x are x cubed. Okay, moving along. So now I have 6. Negative 2x squared would give me positive 4x squared. And then 3 squared is 9. So put that in your calculator. 6 times 4 times 9 gives me 216 x squared. Moving along. So this is 4. And then negative 2x to the first is just negative 2x. And then 3 cubed is 27. So 4 times negative 2 times 27 would give me negative 216. And then this would just be x. And the last one is, this is to the 0 power, so that kind of cancels out because it's just 1. 3 to the 4th power is 81. And so that's my last term. I don't know if this is necessarily that much quicker than just expanding it out, but I kind of like this, having that opportunity to be able to do it this way. So I would like you to practice this, because I think it does take some time, right? But again, the process is fairly basic. It's first term to the highest power, second term to the lowest power. And then basically you just kind of, the first term gets lower in powers and the second term gets higher in powers. All right, move on. We're going to move on to page 85. So on this one, I'm going to do a few with you, and then I'm going to do probably a few of these. I'm going to do 1, 3, 4, 6, and 10. And then you guys are going to do the rest. All right, so let's start with number 1. So on all of these, it asks you to find the sum or difference in numbers 1, 2, and 3. So when you do the sum of polynomials, all you're really doing is combining like terms. Generally, my first step is just to rewrite this polynomial, or both polynomials, without parentheses. So just kind of rewrite it without parentheses. Next, you're going to put all of your powers together. So because you're going to write this in standard form, start with your highest power of x. So I get negative 5x squared, and then negative 6 and positive 7 is positive 1x. And then 18 and 8 is 26. And that's it. That's all you do when you add polynomials together. The next one we are doing is subtraction. So this is slightly more challenging. So the first polynomial, I really don't get anything different because I'm just going to rewrite it. But the second one, you're multiplying everything by a negative. So this becomes positive 11 to the x fourth minus 5x squared plus 7x and minus 13. So obviously you have a lot of terms here, so just kind of make sure you're keeping track of everything. I have negative 11x to the fourth and positive 11x to the fourth, so they cancel out. So I'm going to start with now x cubed. So negative x cubed, doesn't look like I have any others, so I'm going to write that in my final answer. Negative 3x squared, negative 5x squared is negative 8x squared. 10x and 7x gives me 17x. And negative 2 and negative 13 gives me, negative 15, not positive. And that would be my final answer. All right, so that's addition and subtraction. What we're going to do next is find the product. So you are going to multiply. All right. So when you multiply again, just keep numbers with numbers, powers with powers. So x's with x's. So first thing, 2x squared times 2x cubed. 2 times 2 is 4. X squared times x to the third, you add your exponents and get x to the fifth. 2x squared times negative x squared, I get negative 2 x to the fourth because I added my exponents. 2x squared times 3x, I get 2 times 3 is 6. X squared times x is x cubed. And then 2x squared times negative 5 is negative 10x squared. And that's it. That's all you do with product. Now the products can get a little more tricky. So if I have like 3 binomials, I can't use Pascal's triangle for this one because their binomials are not the same. So what my strategy is, I generally take the last 2 and I FOIL them out. So I kind of have the x plus 1 is going to kind of come along for the ride. And then if I FOIL this out, I get x squared plus 6x minus 2x is plus 4x, and then minus 12. So I get that. And then I go ahead and distribute through with the x plus 1. So at this stage, then I would go x times x squared, which is x cubed, x times x to the fourth, or I'm sorry, x times 4x is 4x squared, x times negative 12 is negative 12x, and then I'm going to multiply through by 1. Remember, your last step should always be to write your final answer in standard form, but also to combine like terms. So x cubed, and then put the x squareds together, put my x's together, and that's my final answer. All right, I'm gonna go through one more Actually, I'm not. I was going to, but I'm going to have you guys try, if you're doing the Pascal's triangle, there's 2 on your paper. I think it's a good idea for you guys to try them. You could actually try them with number 9 too if you wanted, because it's a binomial raised to a power. But I think that's a good idea for you guys to practice that, just because it will give you a good practice on Pascal's triangle if you're indeed doing it. I will have you guys ask questions, try your practice, make sure that you're understanding this. If you have any questions on the multiplication, the addition, subtraction, or Pascal's triangle, bring them to class. I'm going to reiterate this again. This is a very important unit. It's important that we have this unit mastered before moving forward. So if you have any questions, please don't hesitate to ask as we go through. All right, good luck.